In SimScale, it's so easy to maximize the value you get out of your past simulation data. When you've got some data that you want to use, like we're showing here for a valve, you can very easily build a physics AI model out of that data so that you can reuse it in the future to make physics AI inferences. Let's have a look at how that AI model can be trained. All you need to do is go to the model training part of SimScale and then select the data that you would like to use. It's very intuitive and very easy to set up the results that you want to get out of it. We automatically segregate data during the training process, and then it runs on our GPU infrastructure in the cloud. As you can see here, this model with 82 simulations runs in approximately 1 hour. And you can then check the results and publish that out to your community of users to make use of. So within an hour, you've already got a physics AI model published out to your community of users using that data that you already had built up in your organization. So we can see here a direct side-by-side comparison of that physics AI model versus the full PDE solve of the CFD data, showing a very good correlation of the results, so you would be able to use it. So where the value of this really comes in is when you have a new product design project that has a relatively high carryover. So say you receive an RFP to produce a higher flow rate hydraulic valve. You can easily edit your existing design to increase the bore diameter of the ports to allow a higher flow rate. When you want to then analyze this and understand how this would perform in CFD analysis, you don't have to wait a huge amount of time for your results to come through. We can see here the performance of the original model is pretty good at the flow rate regime that we already had with that extra 7mm hole. However, when we push outside of that parameter space to much higher flow rates that the AI model hasn't previously seen, we see a 0% confidence score. We know that the AI model is extrapolating data here, so the next thing we would need to do is generate some more PDE solve data to add to our AI model. So here you can see another experiment run being set up, a CFD sweep of 40 flow rates on this new valve design. And then what we can do once those results are available is we can retrain the AI model. So these AI models, the physics AI, is always learning from the additional CFD data or FEA data or whatever physics you have to have a better model that can predict your designs better in the future. So now we just redo the training with a new version, and then we can publish that new version out to our engineering community that covers both valve design types. So next time we have an RFP come up that requires a higher flow rate valve, we've got one that covers a wider design space, so it's always getting better. Again, here you can see that this is completed in our GPU infrastructure in just over an hour again. So the final check is, how does our new design with 7mm bore ports work with this new AI model? Well, we can quickly see that here in SimScale. We can do a new prediction of the physics model with that higher flow rate, and then we can see the results plotted directly on our new CAD. So we have a much higher confidence, we can see nice pressure results, and we would use this to make design decisions. So then we can just see the two results side by side, and there, within 2 hours of elapsed time, we have two physics AI models.